Hello friends, in this video we'll discuss about temperature and temperature scales. I hope you have gone to my previous video for better understanding of this concept. So what is a temperature? Temperature is measurement of hotness and coldness of the object. So how hot and cold is the object defines its temperature. What is the importance of this temperature in thermodynamics? Let's understand first. So, as we already discussed the thermal equilibrium. So, what is thermal equilibrium? When two objects are at the same temperature, they are called at thermal equilibrium. It is different from thermodynamic equilibrium. In case of thermodynamic equilibrium, we have to satisfy three conditions: mechanical equilibrium, chemical equilibrium, and thermal equilibrium. So, this thermal equilibrium is related to the temperature. When two bodies are at same temperature, they are at thermal equilibrium. How these two bodies will come at the same temperature? Here the body is at 0 degree centigrade and 100 degree centigrade. When we touch both of this body, the heat will transform from high temperature body to low temperature body, and eventually both the body will come at 50 degree centigrade and there will not be further heat transfer. So at this moment the body will be at thermal equilibrium. So to attain the thermal equilibrium, both the body should be at the same temperature. And to know that these bodies are at the thermal equilibrium, we should also know the temperature of these bodies. So it is very important to measure the temperature of the body in the same units. So we'll understand how many units which are commonly used in the for the temperature measurement. So here, this is the third point. Equality of the temperature is the only requirement for thermal equilibrium. So let's discuss about the various scales for the measurement of the temperature. So there are the scales are categorized in two headings. One is ordinary scales, Celsius and Fahrenheit, and absolute scales, Kelvin and Rankine. So how they are distinguished? Absolute scale means where the molecular motion cease to exist. Means there is no molecular motion inside the object, and object at complete rest, or it's at minimum energy. So let's understand, absolute zero is the temperature at which the system is in the state of lowest possible energy. Molecule approaches this temperature, their movement drops to zero, so they are at very minimum energy level or almost zero energy level. This is the lowest temperature can be measured by gas thermometer, and no electronic device can work on at this temperature at the absolute zero, because there is no motion, so electronic device needs molecular motion to function. So there is no electronic device can work at this temperature. So you see, Kelvin is 0 where molecular motion is 0, and Rankine is also 0. So these both are the absolute temperature scales. Why Fahrenheit and Celsius are the ordinary temperature scales. Celsius is defined for the water. The 0 degree Celsius is the pure water freezing temperature, where 100 degree Celsius is the pure water boils. Whereas Fahrenheit is defined for the brine liquid. So we'll see in next slide. Absolute zero is for 0 Kelvin and Rankine, which is absolute temperature scales, where freezing point of brine defines the Fahrenheit scale, is a reference temperature for freezing point of brine, where for water it's 0 degree Celsius. Triple point of water is also very close to it for the Celsius scale, and boiling point of water also define the another extreme of the degree Celsius scale where water boils. So we have to remember one thing, that all the temperature scales are linear in nature. Means Kelvin to Fahrenheit conversion, or Celsius to Fahrenheit conversion, or any scale to any conversion are linear in nature. Any temperature scales can easily be defined by a straight line, which is A plus B into small t. So this small t is one temperature scale and this is another temperature scale. So if you remember any 2 points, then you can find out this A and B. Like if you remember that at 0 degree Fahrenheit the Kelvin is 255.37, and at 32 degree Fahrenheit the Kelvin is 273.15. Then by using these 2 point of degree Fahrenheit you can get the Kelvin conversion formula. Similarly, for the degree centigrade also, if you know 0 degree centigrade, the temperature is 273.15 in Kelvin, and at this temperature 99.98, 373.13. So by using these two temperature, you can find out this A and B value, and you can make a formula for conversion of Celsius to Kelvin. Similarly, you can use any other scale to convert any other scale by getting 2 points. So you must know the 2 points for this for to get the formula. So we just get a, this is the chart where all the conversion formulas are given. So using this chart you can convert any temperature scale into another temperature scale. Okay, so now we'll solve some problem. uh, Basically I want you to solve some problem, and you can discuss these problems in comment below if there any problem. So first is the during a heating process the temperature of a system rises 20 degrees centigrade. So what will be the rise in Kelvin, degree Fahrenheit and Rankine? So you here I can give a hint that rise in the Kelvin will be 20 degrees centigrade only, but rise in Fahrenheit or Rankine may not be same as 20 degree. So you just have to find out what can be the reason for this. Okay, and now what is the ordinary and absolute scale that we already have discussed. And yeah, this is one of the another interesting question. The consider an alcohol and mercury thermometer that read exactly 0 degree at ice point and 100 degree at steam point. The distance between the 2 points is divided by 100 equal parts in both the thermometers. Do you think this thermometer will give exactly same reading at a temperature of say 70 degree? Explain. So you must understand or remember that all the temperature scales are linear in nature to give the answer for this problem. Okay, thank you very much.